Hello to everyone. My name is Yerjan Ozakbayev. I'm representing DataMine UK office. I am geologist. Today I'm going to show our functionalities which relates with implicit modeling in a Studio RM. Let me share with you what's going to be happen. I'm going to run the webinar. Then after webinar, we will have, let's say, 5 minutes for question and answer session. Then in a case if you have a question after that, and then I will not answer for that question, you can always contact us via email or directly to me, and then we can discuss. Okay, let me start my webinar. Okay, guys, as you notice, maybe if you are using the latest version of Studio RM, as you notice that in Studio RM we have a new geology tab, geology menu here. It was actually implemented. We have that menu since version 1.6, just recently, actually, maybe 2 months, 3 months ago. Okay, and then you can see here we actually grouped all the comments which relate with the implicit modeling under one geology menu. Okay, and then some of them I'm going to show today. Let me just to share with you my experience with implicit modeling, and then just let's give you kind of overview what we usually do, and then what kind of solution we have when we do the interpretation, geological interpretation or interpretation using the grades. Okay, we usually actually there are two approaches nowadays. One of them is a classical sectional interpretation. Let me show you here examples of that. We usually create the strings section by sections. Then let me load my drill holes. Yeah, we usually create this strings section, series of strings section by sections. Then after that, if I go to here, zone, let's say the zone number 1, we have those polygons here. Then after that, we're linking them, and then creating the closed volume wireframe, right? ls, something that way. Yeah, and then something that way. As you know, that way actually it takes quite a lot of time. That's why it's quite, let's say, popular and quite common in mining industry that people use the solution from implicit modeling, right? And now also we have that solution in Studio RM, as I said before. And then I'm going to start with Wayne today, with Wayne modeling. But if I say about the implicit modeling, I just want to say that what is the advantage of using the implicit modeling? This is actually, of course, this is speed. Your speed will be much faster than if you do, let's say, the sectional interpretation, but also it depends on projects, right? And then we had some projects in the past that, I mean, the real project in the past that we spent more or less the same time if we do the sectional interpretation when we do the implicit modeling. And the outcome of that, of course, if you spend more time, if you consider all the details, and then your result would be robust, and then would be reliable, and then would be good to run, and then to do the resource estimation, right? And just a few things I want to also mention here, because a lot of people ask me, what do you think about what is the best solution to use, implicit modeling or classical sectional interpretation? My position is here is I'm neutral. I always kind of saying that I think it depends on situation, but I always use this kind of goal that try and impress, right? In this case, you can try and then see if it's which is the best solution using the sectional strings interpretation or do the implicit modeling. It depends on situation, depends, but the goal, everyone knows that the goal is like to achieve good, robust interpretation, right? And then as you know, like for example, if you compare all the stage of resource modeling, resource estimation, and then as we usually spend most of the time for the geological interpretation, right, or geological or interpretation of using grade, right? That's why like this is quite important for all of us. I mean, like to achieve good result, even like in terms of the estimation, even like if it's if you do the like any statistical analysis, the geological any like a block modeling, it's everything relates, estimation itself relates with geology. If you clear with if your project, I mean like what you're doing, if you're clear with the geology and then you know the behavior of your structure of your let's say structural geology, in this case it will be much easier when you move to the next stage of your project. It would be much easier to do the even statistical analysis, block modeling, estimation itself. Okay, so that's why this is quite important, and it's why like we should spend more time here, and then to achieve very close, let's say very reliable interpretation and so on like this. Okay. Okay, guys, this is the old way, let's say the classical way, sectional interpretation. Let me unload. Okay, now I'm going to go to here under the geology. We have vein. I'm going to start with vein structural model, right? If I click here, vein, then I also have my drill holes here. Let me load my drill holes. Yeah, then after that, we have a data selection here. Then let's select the data. VB holes, my drill holes. Then if I go to here, I can select my lithology. Yeah, and then system automatically recognize the lithology codes, what I have in my drill hole file, right? Then after that, I have here the attributes, lithology codes, which came from my drill hole file. Yeah, and then I have basalt, breccia, sandstone, siltstone, soil. Let me use siltstone. And then system automatically recognize them, all the intervals of siltstone. You can see here. Then if I go, for example, now to the section view, let me just go to the section view, and then you can see them probably better. Taking section. Yeah. And now what else we can see? Here we have the options here, default uncertainty. What is this actually? This is something which relates with your snapping to the intervals or honoring to intervals. For example, if you reduce your your value of your uncertainty to, let's say, 0. That means when you check, once you finish your wireframing, you can check you can check the snap of the intervals, your wireframe, and you can see your wireframe will be snapped exactly to the interval, exactly to the top and the bottom of your interval, hanging wall, foot wall of your interval. Okay. But also we have options here if you can increase as well. I mean, like if you use this one, for example, like this, you can increase, of course, like this. When you increase the uncertainty, that means like you kind of allows the system to generate the wireframe, which would be more smoother, and then based on the structure of the wireframe, let's say based on the geometry of the wireframe, the system try to create as the wireframe as smooth as possible. And that's why like there's some places you can find that like the snapping part would be ignored, right? That's why like we usually have quite low value of uncertainty. Okay, something like this. Okay, the next one is we have uncertainty column here. What is this? It's quite nice. For example, if I use here 0.001 value of uncertainty, I'm going to apply that value uncertainty for all my intervals, for all my drill holes. But in a case, for example, if you want to apply different, let's say, the value of uncertainty to the intervals, for example, for siltstone, you're going to apply the uncertainty 0.01, but for the, let's say, the breccia, you're going to apply, let's say, 0.5 uncertainty, right? And then it's also possible how you can do. I have a, let's say, one of the example is I have a drill holes. If I open it here, it's a typical drill hole files in Studio RM, but there's one extra column which is here, uncert. Yeah. That means like, as you can see here, I have the intervals from 2, this from 2, and then for each interval, let's say for each sample here, I can apply the uncertainty. If I go to here, you can see, for example, for this, I'm applying 0.25. Yeah, for the rest, I'm applying something like 0.001 and so on like this. That means like for each interval I can control, I can apply the uncertainty. Yeah, for each lithology codes, lithology types, as you can see here. Okay, if you load that VB holes here, I mean, if you load your VB holes in the 3D window, then after that, what you can do, just select here that column, uncertainty column, and then the system would, instead to use that default value 0.01, it's going to use that uncertainty from your column. Okay, in this case, I will not use. Let's move on. The next one, what I would like to show you guys, it's the section control section editor. What is this? Actually, this is kind of options to control your view. You control your section view. For example, when we create the wireframes, then after that, like if you need to do some adjustment, let's say applying, we can apply the trends, we can apply some additional points, right? In this case, it's quite nice to go to here and then apply let's say the distance, and then you can move for one section to another sections, and then you can do this. You can check, and then you can create additional points, right? You can do, of course, from here under the view. Yeah, you have the same menu, for example, here, clipping, or you can see from the right hand side you have a view toolbar. You can do it from here, but we put it here just because of I think it's much comfortable to work with one window and so like this. Okay. Okay, let's move on. What else I would like to show you? We have edit samples, additional points, boundary controls. We're going to run, and then we're going to see. I'm going to introduce you with all of them. Okay, but for now, what I'm going to do, I'm going to run by default, I'm going to run and then generate the wireframe. There's an option to generate the wireframe, creating the only hanging wall wireframe, right? Only surface of hanging wall, surface of foot wall, and also I can generate both. That means that wireframe would be closed volume wireframe. Okay. Now, if I click compute surface, yeah, and then within a few seconds, the system automatically generated the wireframe. As you can see here, let me show you. Yeah, zoom in. We created the wireframe here, and then if I go, and then you can see the snapping. Yeah, you see the slice. It snapped very well. Yeah, yeah. This is I think because of the my section view is a bit shifted. Yeah, you can see now it snapped very well. Yeah. And now if you can see in a 3D view as well, let's have a look in 3D view. Format, and then here I go to see the whole subject. Yeah, this is your wireframe that you created for Silstone. Okay, then what else we can do here as well? Let me just untick now. Let me try to generate the hanging wall, and then click here hanging wall, and then compute surface again. Yeah, all series of your wireframes, it's saved here. I mean, like as temporarily, and then you can see, for example, what you did, what you did previously, and then it's your new one as well. For example, this is my hanging wall wireframe. Yeah, and then that one was my previous one, the closed volume wireframe, as you can see here. Yeah, if I zoom in like this, you can see probably better like this. Okay, guys. The next one, what I would like to show you, then let's say that we created I created my wireframe, but I found that some places I need to do some adjustment. I need to change the shape of the, let's say, the wireframe. What I can do, we have options here: edit samples, and then we have additional points. Yeah, which allows me to do some adjustment of my wireframe. I'm going to show you now. Let me go to the section view, take a sections, and align outside. Yeah, let's say, for example, here you can see my thickness of my ore body is changed because I don't have a data here, but I can control if I need to, let's say, if I need to increase my thickness of my ore body, particularly in that section and that place, I can do via additional points. Okay, but before to do this, we have edit samples. I'm going to show you what is this. Edit samples, there's options. I can select the intervals. If I click pick samples, I can select the intervals, for example, here. Yeah, and then you can see you have the red ball and green ball, which represent your hanging wall and foot wall, right? And then here the options from use and then to use. You see here. What is this? That means like there's options when I select that interval. If I see, let's say, if I see that like that interval of hanging wall of that interval, I should increase, or I should, let's say, to change. I can say to system that if I unclick here from, untick this one, click apply, and now you can see my the red ball is disappeared because of the system now actually is going to ignore that hanging wall of that interval, and it's going to regenerate the wireframe using the only foot wall point here. Okay, and then also I can do for another section as well. Okay, sometimes it's quite nice and quite good to see. For example, let me just run, and then we can see the result. I arranged that one and I set system that like we need to ignore that interval from the top, but the bottom, it should be snapped to the bottom. And then if I click here now, compute surface again, Yeah, I have another wireframe, and then let me untick my previous one, and now you can see, yeah, and now you can see that like that way is the hanging wall of that interval, it was ignored because I set system that like don't use it, and then here I still snapped my foot wall. This is how it works. Okay, let me go back and let me pick this interval and let me say use from as well. Click apply. Yeah, I'm going to use both of them. Okay. Another thing what I just what I also didn't say, this is about the reversed and the reverse here, to reversed and then from reversed. And yeah, what is this? We have a kind of options in the Studio RM in implicit modeling. We have options to create, let's say, double hanging wall points or double foot wall points. Let me explain to you what is this. If I just now let me create this thing quickly. If I go to data, I can show you. One moment, please. Sorry. Yeah, I need to go to here, and then I need to create a new object, and let me create this thing. Yeah, what I'm going to do, I'm going to show you when you're going to use this one. If I click here at, for example, you have a situation, like this. There's a section view for you guys. Then if I go to here, new string again. Yeah, and then you have a drill holes which goes that way. Let me go just generate the drill holes. Yeah, from here to here, like this. Yeah, this is your drill hole. In this case, for example, if we use by default, let's say that one should be your hanging wall, this is your foot wall, but in reality, it's not like this, right? That's why there's options you can use reverse. That means like, for example, from your hanging wall, that means like those 2 points would be hanging wall, right? And then you can use this is for the creating the wireframes. I hope it's clear. Let me delete. Okay, let's come back to here. Then probably it's one more time. I can go to here, and then you can see. For example, if I click here reverse, and I click apply. Now, for example, both points here shows that it should be the points of foot wall, right? And the other way around, the same. If I click here, if I click this one, apply, then this shows that like these 2 points would be used as a foot wall points, and so on like this. Okay. Then as one more options there as well. For example, if you use like this, yeah, use reverse, click apply. That means you're changing the points. I mean, like you're changing the direction of the points. Now that points becomes foot wall. That points becomes hanging wall. Yeah, as you can see here, it was red, green, red. Yeah, it's because I changed here like this. This is kind of options you can apply to generate the wireframes. Okay, let me go back and then let me apply and then create the normal as it was before. Okay, another thing what I would like to also show you that these options kind of ignore the gaps as well. If you click here, ignore the gaps, what you can see, by default, there's a merge. That means like if you have a, let's say in your interval here, you have a lithology code like siltstone here, and then you have a gap here, and then you have another siltstone here. When you click ignore the gaps merge, that means like that the system is going to ignore that gap between 2 siltstones. That's why like it's going to merge both of them together. That's why like, there's options here. Okay. And then also there's another one is ignore holes with gaps. That means like you can also say that like if you have Siltstone intervals on the top here. You can also arrange the system will go take the top interval or to the bottom interval. You should manage this via that from, to, and reverse options combination with the ignore hole with gaps. Okay. In a case if you in real project, I don't know if you're going to, I don't know, do some practice, and then in the case if you have any questions, just let us know, and then we will help you with this. Okay. I'm because of this webinar, I don't want to spend so much time for this, and then we're going to move on. Okay. Then if I go back now, then we have also additional points. How it works? If I click here additional points, and then here I can generate the additional points for hanging wall. I can generate additional points for foot wall. Let me generate, and then you can see the result of that. For example, I can say system to create, yeah, let me do like this way, create the shape of the wireframe that way, and then my foot wall, shape the wireframe, let's say that way. Click done. Then if I recreate the wireframes, click compute surface. Yeah, and now system is recreated the wireframe using the last changes what I've done. This is my previous one before, this is my new one. As you can see now, I changed the shape of my wireframe based on those hanging wall and foot wall points. Okay. Another thing what we can see here as well, we have a use additional points, and then we have here under that use additional points, we have add samples. If I click here add samples, for example, I want to change the thickness of that area in my section. If I click here and then say, let's say the thickness should be like this, done. It's kind of additional sample options, and then if I click compute surface, and the system recreated the wireframe again. Yeah, and then let me untick my previous one, and now you can see, yeah, I use my angle foot wall points, plus I use my additional points, additional sample as well here. Yeah, now you can see, you can change. Then if I have a look my wireframe in 3D environment, if I go to here, you can see that it's, yeah, you can see that, and then this one was applied, yeah, and then we applied for one section, and then also it's the same way you can do for section by sections, and then until you achieve good result of your wireframe, which is close to reality. Okay, then if I go back to my align, go back to my section view, what we can see here as well, let me go back, and then also there's another options here as well. There's options kind of creating the trend, add the trend points. Let me create the trend. If I click here, creating trend, I'm going to change, let's say, the trend, entire trend of my wireframe. If I click here, I'm changing trend. Let's say it should goes, the trend should go that way, for example. Yeah, something like this. Then after that, what I'm going to do, I click compute surface again. Okay, let me just untick. Is it too much points? I think. Let me just do one more time. If I delete everything now, then if I use my trend again, yeah, if I click done, then if I click compute surface, yeah, and now you can see my system format wireframe slice again, and now my system, actually my previous one and old one, now my system follow my trend what I created, as you can see here. Now I change the trend of my wireframe. Yeah, if I go back to my 3D view, I can see, yeah, I completely changed my trend of wireframe. Now it goes like this. Okay, guys, then move on. Next one, outside. Yeah. Then let me delete my trend as well from here. What else we have here as well? I want to say about a few words about uncertainty columns. This is also options here when you create the additional points, or when you create the, let's say, the hanging wall points and then footwall points trend as well. You can also arrange the uncertainty for those points which you created. For example, for that point, yeah, I can say here, if I arrange the uncertainty 0, it says set value 0. That means like the system is, we're forcing system to follow that points. But if you, let's say, increase this uncertainty value, that means like in a case if the system applying the, let's say, the mathematical functions that, like, if it's see that like the shape it should follow, let's slightly up or slightly below of that, it's would be ignored, and then it would follow the points, but it would be snapped to the points. Yeah, it's more or less, it works the same like uncertainty here, and then uncertainty what I explained to you before, it's the same, but this uncertainty relates with those additional points. Okay, then let me delete, then let's move on. Then also what we have here as well, we have also the boundary. If I click to boundary, and then if I go to here view align, let me create a boundary. If I untick my wireframes, and then if I click none, and then if I go to plan view, then align, yeah, I can generate the boundary. How its boundary works here? By default, you can see the boundary, it's here auto alpha shape. Yeah, and then also you have align, square, radius, radial interpretation as well here. But also there's options using the custom boundary. I can generate myself the boundary of my wireframe. I can do now, for example, if I click here custom, if I click here design new perimeter, if I click, now I'm going to generate the new boundary, let's say from here. Something like this. Yeah, and then done. Then if I now compute surface, yeah, as you can see, for example, I generated the new wireframe with the new boundary here. Yeah. Okay, it's like this. Okay, guys, then move on to the next one. Also, we have a controls here as well. If I go down, here you can arrange the continuity of your, let's say, the search ellipse to generate the wireframes. Okay, is a 25 meters. That means that one is a default one, which system used by default. The 25 meters because the distance, approximate distance between my sections is 25 meters. That's why like it was by default 25 meters, but you can increase, decrease as well. Okay, the minimum thickness as well, you can arrange, for example, below the minimum thickness 0.05, the system will ignore, right? And then if you increase the thickness more than 0.05, let's say 1, 2, and then in this case the system will generate and use the points which is above that value of the your thickness. Okay, this is the maximum thickness 20 is 20 meters, always like by default, but also if you click here maximum thickness, you can also use your custom one. The trend smoothness, I mean, like if you want to smooth your wireframe even smoother than this, you can go to here medium, very low, high, very high, and so on this, and also you can play with this trend smoothness 20%, 30%. which force the system to when generate the wireframes to create the wireframes much smoother or more, let's say, straight, and so on like this. Okay. What else about Wayne surface? Another thing what I would like to show you here, that there's an option as well, create a trend surface as well. If I click now, let me don't use my, let me unload this. Let me create the one more wireframe, and then I can use the trend surface. And then after that, I will show you what is this and I explain to you what's this. Click here. When I click trend surface here, the system automatically create wireframe, and also if I take this, if I take this is the wireframe that I showed you before, and also it generated a trend as well. If I click here trend, this is the trend of the wireframe. Okay, usually the trend, this is kind of the, usually the trend is generates between your hanging wall, foot wall surface. Yeah, this is your trend. It's quite to see, and then quite nice to use, for example, when you do the series of wireframes, and then you can see how trend is changing of your deposit of your ore body, and then based on this, maybe you can get some answer for the angle, for azimuth, for dipping of your ore body, continuity of your ore body, and so on like this. Yeah, this is for that. Okay, guys, this is actually about the Wayne modeling I showed to you. I think this is what I wanted to show for Wayne modeling. Next one, I'm going to move to the categorical shell, creating the shell categorical option to create the wireframes. But here, one more thing I want to say here, that when you generated so many series of wireframes, you should know, for example, if you unload the data, that means you're going to lose all of them, right? And then let's say you created wireframe which is okay, which you found it's good to use for the estimation, and then you should save it, data save fast, and then you should save this one. The rest you can unload. Let me unload now. I don't need to save any wireframes. That's fine. Then if I close this one, let me go now, and then let me show the categorical options here. Okay, if I click here categorical, there is options to choose, let's say, the lithology codes or any, let's say, unique codes. If it's, let's say, alphanumeric, if it's alphanumeric value, you can use the unique name of that code. And also the categorical options here, you can also apply numeric value as well. I mean, like, for example, if we're talking about the zone, if you have zone 1, zone 2, zone 3, zone 5, if you want to generate the wireframe using the, let's say, zone 5, for example, in this case, it also allows you to generate the wireframe. Okay. Now, step by step, what we should do. The first thing what I would like to say here is the same options here, just load the wireframes or load the drill holes. But before to load the drill holes, I want to show you why we have that option here as well. This first one, optimize ore and waste. I want to show this one with combination with the categorical shell, creation of the shell. Okay. Optimize ore and waste is our process which called Compass E. It's quite old one. I mean, like we have that from a long time back, that process. But this is process. It's very nice because it allows you to composite and then define your intervals ore and waste by criteria. Okay. Let me show you something. If I click here restore, I already done something here, and then I have VB holes. This is my drill holes which I showed you before, and also I'm going to create a new drill hole file. Then if I go to here, I'm going to use gold value to create a composite, and also here under the parameters I have these options to generate to generate the composites, select the and then create the composites by cutoff. I will explain to you what is this. It says here the one. That means is I'm going to use to generate the composite 1 gram of gold. All the samples above 1 gram of gold, right? The rest would be waste, yeah, based on these parameters. And also I can arrange the minimum ore, minimum length of the ore, maximum waste, and so on like this. It's kind of different rules you can apply, so on like this, yeah. Then what I'm going to do now, if I click here, okay, yeah, and then I already have that file. If I click here, drill hole compass C, if I double click, the good thing of that compass C, the system automatically also generate the OV code, right? The kind of column attribute which split up your samples by waste and ore. Oh, sorry, yeah, by waste and ore. For example, 1 and 0. You see here that this interval, that samples is 5.5 gram of gold because it's above than 1 gram of gold what I used when I run compass C. That's why it's ore. Everything below 1 gram of gold, it's 0. Yeah, that means like I coded all my intervals 1 and 0, ore and waste, and then after that, what I'm going to do, I can use this actually column, that attribute, to generate the wireframe as well. Yeah, this is one of the examples to use the ore and waste here. Okay, then in this case, I will load the drill hole compass C, and then if I go to here, drill hole compass C, this here column comps E, this OV code, and then here it gives me 0 and 1. If I click 1, and you can see that all those red intervals represent ore. If I click 0, all those blue represents waste. If I click 1, the same uncertainty here as well. Then there's options also create a trend. This custom trend, creating the ellipsoid, I'm going to show later on with not with this process with the gray shell, because they're exactly the same. Okay. Here I'm going to use default trend. If I click here view, this kind of by default, this is the kind of trend which the system is going to use. Yeah. You see like a series of ellipsoids here. Then also here we have a resolution percentage extra. This is related with the smoothness of your wireframes, right? You can also play with this. Then after that, I have to click compute surface. I will not do this because it takes 2-3 minutes to generate the wireframe. I already have that wireframe, which is here, wireframe code. Yeah, and then if I remove my ellipsoids, you can see them. You can see my wireframe here. Yeah. Yeah. Those intervals here actually I used the wireframe with a different, let's say, cutoff. Probably this was the reason why. But the shape of the wireframe looks nice, and then it should be like this. And also, when you check the honoring of your wireframe, let's say to the intervals, it's also quite good without any problem. You can see like this. Yeah, this is the how it works. The categorical surface. Okay, now let me unload everything and then let me show one more. If I go back from here, I go to the great shell. If I go to the great shell, there's another one. This great shell command here allows you to use numeric values. Let's say allows you to use the grade. For example, if you want to apply the cutoff, if you want to use the cutoff, let's say 0.5 gram of gold, and that means like you can apply, and then the system is going to generate the shell based on this cutoff. This is why we need this great shell. If I go to now to my drill hole file, which is here VB holes, yeah, same. Then if I go to here drill holes column, and now here I'm going to choose the gold. Then here I can see that my cutoff is 0. That means everything. But if I put here, let's say 1.5 gram of gold, and now you can see I have less intervals because it's quite high cutoff, and so like this. If I put here 3 gram, yeah, even less, yeah, like this. Then another thing what I'm going to show you, let me put 0, let's use everything. Here the create the trends, it's the same what I showed you in the categorical, default one and the custom one. The custom one I didn't show. There's options, I mean, like when we want to define the trend, and then there's the options to generate them ellipsoids, yeah, yourself, and then after that the system will use those ellipsoids to generate the wireframe. Okay, let me show you how it works. If I go to here, view, align, I have here the options. If I select, let's say, some of the drill holes here, and then there's options I can do, create ellipsoids from selected data. If I click here, I create the ellipsoid for particularly for that area where I selected the data. Then after that, if I go to another one, if I click here, let's say something here, create ellipsoid as another one, and then let me create the ellipsoid here. Let's say here, create the ellipsoid. Yeah, I think it's better to if I delete one of the ellipsoid, let's say that one, or I can change. Let me better to probably quickly to create the one more ellipsoid here. It's probably better to do like this way. One sec, please. One ellipsoid here, and then one ellipsoid probably here is enough. 2 ellipsoids would be enough. Yeah, 2 ellipsoids. Yeah. And now what we can see here as well, those trends I'm going to use to generate the wireframe. This is by default, right? Of course, the system, I think we need to do some adjustment, and also we can do as well. How we can do the adjustment of my ellipsoids? Yeah, if I go now to here, edit existing ellipsoids, I can select my ellipsoid, and then I can say, here the azimuth is 0, then deep, let's say 5 degree, roll is 0. Click apply, and now you can see I changed my ellipsoid. The same here, I can put here the 70 degree my long direction by Y, X direction I can put 50, and then here put 20 by Z. Click apply. Yeah, now you can see my ellipsoid. Yeah, if you see my plan view, I think it's a, yeah, it goes that way. Then after that, if I move to the next one, if I click here quickly, same for here. Let me say here's a 20 degree, then here all is 0. Here maybe put it 40, just make it a bit smaller, and here put 60, and put here 20. Click apply. Yeah. And now you can see my second ellipsoid as well. If I go to click OK, if I go to my section view now, somewhere here, for example, align outside. Yeah, now you can see outside. Yeah. If I go to format, yeah, yeah, and now you can see my ellipse. If I get wide a bit, you can see that if I go to the section, you can see my ore body is striking that way. That's why I can change my ellipsoid, and then also I arrange my ellipsoid that way as well. Yeah, if I see again everything together, this is how we can create the ellipsoids. Then after that, what I need to do is the same stuff what you saw before, and then after that I have to click compute surface. As a result of that, you can get that file, great shell ordinary. Okay, yeah, this is the wireframe which we created. If I click here and then make this one intersection, let me just show you quickly. Yeah, then if I go to here, edit interactively, let me put like this. Then if I untick my ellipsoids, which I generated, now you can see the result of that. Yeah, this is my ellipsoid. Yeah, this is the wireframe. You can see it that way as well. This is the way how we can use, let's say, the grade from your drill holes, and then based on this, we can generate the wireframe. Okay, this is about grade shell. Then if I go back to the geology, the only two things left here, there's a group and assign. What is this? I'm going to show you this one as well very quickly. If I go to here, the formats now, if I, sorry, view and then none, yeah, I can see my wireframe. And then now I'm going to go to geology and then go to group. How it works. During the interpretation, let's say, once you created a series of the wireframes and then you need to do some adjustment, you found that like some in the intervals, maybe you need to merge, and then maybe you should group them, right? That's why like we have options here, grouping and assigning. Assign the individual intervals and grouping. If you have some intervals, you can group them together. I will explain to you how it works. If I go to here, VB holes, then if I go to here, let's say zone, as you know, as you see that like I have zone 1, zone 2 for that drill hole file. And also I can say here the group and then enter. And I have group 11 and group 1 and 2, right? What I can do here, let's put back this one. I created the group. This is the group 11, and also I have 1 and 2 here. Yeah, this is came from my original drill hole file. What I'm going to do, I can say, okay, for this group 11, that zone 1 should be merged with zone 2 together. And then the system is going to generate a new column, new attributes with name as group, and then the code would be 11 for zone 1 and for zone 2. Then after that, you can use that code 11 to generate the wireframes for zone 1 for zone 2. Okay, if I click now, apply now, if I remove my wireframes, and then you can see the result. For example, if I remove this one, then after apply, now you can see the system also shows that here that the zone number 1, which is blue color here, change the environment, probably would be better like this. Oh, it's not. Yeah. The blue one is the zone 1, the red one is zone 2. And then if I merge them together, yeah, now is zone 1, zone 2 is both of them together under the 11 code. Yeah. Then after that, you can generate the wireframe based on this. Then if you go to here now, don't need to save. You can save the file as well. That means you're going to change your original file based on this. That means you're going to generate the column in that original file, or you can leave it as it is now. Don't need to change. Don't need to save it now. And then if you go to, for example, grade shell, or sorry, categorical, then you can use VB holes. And now you can see from here, there's a group which we created. Group, and now we can see here 11. Yeah, and then the same way we can generate the wireframe, create the trends, generate the wireframe, and so on like this. Compute surfaces. For assigning, actually, it's quite similar. Quite similar situation. If I click assign, if I use VB holes, and then if I go to here zone, oops, one sec, it's not the zone. Let me load the wireframe. Sorry, drill holes. Yeah, for assigning, click here, click my lithology, for example. Then after that, what I'm going to do, I can assign, for example, for some of the intervals, this is for, it was siltstone. What I'm going to do, select, and then say this interval here should be now soil. If I click here, assign, now it's soil. For example, this one should be soil as well. And so on like this. This one should be soil as well. Then after that, once I finish this, I'm going to recreate the wireframe based on my new changes what I've done here. Okay, then one more thing here as well. If I click here new, also I can generate myself one more code. Let me put limestone, LMST, limestone. Change the color of that. Put here, let's say, I don't know, something that color maybe. You can see better. Then I can say the select mode, for example, that intervals, everything now is limestone. These intervals, everything is limestone, and so on. Of course, it's better to do this one section by section. If I go to here, view align, outside, yeah, I can say this is intervals, or I can select only one interval here, or I can, using my control, I can select a few intervals like this, and then click assign, click assign. Yeah, then after that, go back again to my geology, categorical, and then after that, I can, sorry, not categorical, vein, and then after that, I can use the new assignments, new changes, and then I can recreate the wireframe. This is how it works. This is what I wanted to show today, guys. Thank you very much for your time. And then, as I said before, if you have any questions, just please contact us. We will be more than happy to answer all of them. Okay, and then see you next time. Thank you again. Bye to everyone.